We are on lesson 3.2 today, and this lesson is called Using Parallel Lines and, that's an and sign, so using parallel lines and transversals. So what we're going to do today is we're going to discuss one postulate and three theorems. We're going to actually prove that the theorems are true, and then we're going to do a little bit of algebra with them, and then we're going to be done. Okay, you absolutely have to know these postulates and theorems very, very well. We use them a lot later on throughout the year. One of them not quite so much as the others, but all four of them we do use frequently later on in the year. All right, so here we go. First one's called the corresponding angles postulate. And remember I told you I'd number them with stars throughout the year. This is a 3-star postulate. It means it's very, very, very important. All right, and this is what it looks like. Okay, we have parallel lines. Okay, remember these shaded triangles mean parallel lines, these kind of arrows almost, right? And these are corresponding angles. They're in the same position. Remember, top left or bottom right or whatever. These would be considered top left in both of them. Okay, so they're in the same position. All right, here's what the corresponding angles postulate says. If two parallel, that's important, parallel lines are cut by a transversal, or you could say intersected by a transversal, then the corresponding angles are what? Okay, well, let's take a look. What do you think is true about this angle up here and this angle down here? It looks like they are probably what? Looks like they're probably congruent. And that's true. Okay, now we cannot prove this is true. Okay, we can give lots of examples of it working. If you're taking notes on a typical sheet of notebook paper, you've got all kinds of parallel lines on your paper. They're usually kind of blue in color. All right, and if you were to draw a transversal and then get out your protractor and measure the corresponding angles, whether it's the ones I have marked here, or whether it's maybe the acute angle right here and right here, okay, or maybe it's the acute angle right here, along with this one right here, you'd find out that they're the same degrees over and over and over again, no matter how many examples you do. Okay, now this only works though when our lines are parallel. That's why that's very important that we have parallel lines right here. Okay, so if two parallel lines are cut by a transversal, then the corresponding angles are congruent, and that goes for any of the sets of corresponding angles. If you remember the other lesson, we had 1, 2, 3, 4, 5, 6, 7, 8 all numbered here, so 1 would be congruent to 2. If I called this one 3 and this one 4, 3 would be congruent to 4. 5 right here would be congruent to 6. 7 would be congruent to 8, something like that. Okay, but I just have one pair marked right now, so we know that angle 1 is congruent to angle 2. Okay, that's what the corresponding angles postulate tells us. All right, let's go to the next one. The alternate interior angle theorem. Okay, once again, this has 3 stars. Okay, alternate interior angle theorem. Theorem means we can prove it. We're going to do that here in just a second. Alternate interior means they're between the lines, in this case between the parallel lines, and then on opposite sides of the transversal, but not a linear pair. So you can't go 1 here and 2 up here. Okay, so 1 here, opposite side, down here to 2, or we could call this 3 right here and call this 4 right here and go with 3 and 4. Okay, but I'm just going to do one set. All right, let's talk about what the alternate interior angle theorem says. It says if two parallel, once again, that's very important that the lines have to be parallel. If two parallel lines are cut by a transversal, then the alternate interior angles are what? Well, what do you think is true about that angle and that angle? What do you think? You think they might be congruent? All right, well, let's take a look. Okay, we're going to do a proof for this. Okay, so go ahead and draw this picture on your paper. All right, I basically have it exactly opposite of what the other one looked like with the way the transversal is going, but that's fine. Okay, we're going to call this line L, we're going to call this line M. Remember, if we use a lowercase letter, we can just use a single letter to name our line instead of using 2 capital letters for points. We do that sometimes to just make things a little faster, a little quicker. right? And then we're going to number all three of these angles right here really fast. Okay, so go ahead and get that picture. And then I have a given for you. L is parallel. These two vertical lines right next to each other like that mean parallel. Remember, like the upside down capital T meant perpendicular. This is what parallel means. Right? And then line M. We're going to prove that angle 2 is congruent to angle 3. Okay? Hopefully that's what you responded back there on that question I asked you, where we kind of left the theorem blank at the very end. But we're going to try to prove these two angles are congruent. Okay, so let's start. Statement 1. Well, I only have one given, so it makes sense to start with that. So L is parallel to M, and the reason is given. Now, there's two different things you could do for statement 2. Okay, I don't really care either way, but let's focus on the parallel lines. So it means I'm going to ignore this angle 3. What do we know about angle 1 and angle 2? Okay, what's the proper term for those angles? Angle 1 is in the top left of its section. Angle 2 is in the top left of its section. So what's true about them? Well, it's the thing we just talked about, right? The corresponding angles. If two parallel lines are cut by a transversal, then the corresponding angles have to be what? Well, they have to be congruent. So angle 1 is congruent to angle 2. And the reason? Corresponding angles postulate. You can abbreviate a little bit. I usually abbreviate angle with that symbol. And postulate, I just put like P-O-S-T. Okay? If you don't know what my symbols mean, write it out in words instead. But don't abbreviate so short that I don't know what you mean. Okay? Let's go back to our picture. Is there anything else we know in this picture? How about if we cover up all of this down here? Is there anything you know about these two angles right here? What do you think? Remember what those are? Those look like vertical angles, don't they? You better know this one. What do vertical angles? What do we know about vertical angles? Doesn't matter if we have parallel lines or not. Vertical angles are always congruent. Okay, so let's write that down. Angle 1 is congruent to angle 3. Why was angle 1 congruent to angle 3? Remember, they're vertical angles. What tells us vertical angles are congruent? The vertical angle theorem. I usually abbreviate theorem THM. Okay, that's how I usually abbreviate it. Alright, now, we don't even need to look at the picture anymore. We see angle 1 is used twice. So 1 to 2, 1 to 3. We're kind of going to work our way from this way around. 2, something in the middle, and get to 3. How do we do that? How do we get past that thing in the middle? You guys remember that? Angle 2 is congruent to angle 3 because of the transitive property of what? Well, it's not equality because it's not an equal sign, so it's a transitive property of congruence. Remember, that's actually a theorem. It says the transitive property works for congruent angles and congruent segments, but we usually don't write it down as a theorem. We just say transitive property of congruence. There we go. We just proved that as long as we have parallel lines, these alternate interior angles have to be congruent. It doesn't matter what kind of parallel lines at all. So we proved that it's always going to work. So let's come back here and let's finish off our theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. There we go. 3 stars, you better get it memorized. Okay, let's take a look at the next one. Alternate exterior angles theorem. Once again, 3 stars. Okay, I got my picture over here with a 1 and a 2 again. Outside the lines, in this case the parallel lines, opposite sides of the transversal, but remember, not a linear pair. Okay, so let's write this one down. If two parallel lines, once again, it has to be parallel lines. If two parallel lines are cut by a transversal, then the alternate exterior angles are, what do you think? Looks like it might be true about 1 and 2 in this case. Looks like they might be congruent again, doesn't it? They are. Okay, but it's a theorem, so we're going to go ahead and prove it again. Okay, go ahead and get that written down, and then we're going to prove this. All right, remember, if you ever need to pause it because I'm moving too fast, just pause it or rewind it or whatever. All right, here we go. There's my picture. We're really dealing with 1 and 3 this time. Okay, last time we were dealing with 2 and 3. But 1 and 3 are my alternate exterior angles, but you're going to need 2 to help you along. All right, so get that picture. That's a P and a Q this time instead of an L and an M. Here's my given and what I'm trying to prove. P is parallel to Q is given. We got the shaded triangles here to say that. We're going to prove angle 1 is congruent to angle 3. I want you to try this one on your own. Okay, completely on your own. It's going to be 4 steps. It's almost the exact same as the proof we just did. Okay, so pause the video. Try this theorem on your own. See if you can get it done in 4 steps. Look back at that other one if you need to. And then come back and I'll walk through it real quick. Okay, go ahead. Alright, since you paused the video, you should be done with it by now. If you didn't pause the video, make sure you pause the video, try it on your own. All right, if you get confused, it's okay. It's part of the learning process. All right, here we go. All right, P is parallel to Q, that's my given. Step 2. All right, we know we have parallel lines, so look at angle 1 and angle 2. They're both top left, so we know they have to be congruent because of the corresponding angle postulate. Sorry, that's a really bad congruent sign. Try to fix that a little bit. Okay, corresponding angle postulate. Okay, they're both in their top left section and the lines are parallel, so that has to be true. Okay, come back up here. I'm going to completely ignore this top part this time. And what do I know about 2 and 3? Okay, those are vertical angles. So angle 2 is congruent to angle 3 by the vertical angle theorem. And then I don't even need to look up at my picture anymore. I've got 2 repeated, so I skip right over it. Angle 1 is congruent to angle 3 by the transitive property of congruence. There we go. We just proved that the alternate exterior angles are going to be congruent anytime you have parallel lines. Right? Let's go to the next one. Last theorem. Okay? It's called the consecutive interior angle theorem. Now you'll notice this one only has 2 stars. We don't use it quite as much as the other ones. Consecutive interior means they're on the same side of the transversal. Interior means they're inside. Once again, we have parallel lines here. Okay, so it's going to start off the same way. If 2 parallel lines are cut by a transversal, then the consecutive interior angles are, now look at the picture. Is there any way that they look congruent? Not really. This one looks like it's probably obtuse. This one looks like it's probably acute. Okay, so they're not going to be congruent. So what do you think they might be? What do you think a obtuse angle and an acute angle might be? Especially if you add them together. Consecutive interior angles are supplementary. Remember, what does supplementary mean? It means they add to equal 180 degrees. Now, we're going to prove this one, but it's going to take a little bit longer than 4 steps. Okay, but we're going to do that proof together, and then we're almost done. All right, here we go. So what my picture looks like, we're going to be focusing on 2 and 3. They're the ones we want to prove are supplementary. I've got parallel lines again. This time I called them S and T. Okay, copy the picture down. Get ready to do this proof. So S is parallel, T is my given. We're going to try to prove that 2 and 3 are supplementary. 2 and 3 are supplementary. All right, here we go. Let's start though with kind of the way we've done that in the past. What do we know about angle 1 and angle 3? Okay, look up at the picture. Top left of its little section, top left of its little section, so they have to be congruent by the corresponding angle postulate. Now, we're going to change gears just a little bit here, something we didn't have to do in the other proofs. Because we're trying to prove they are supplementary, which means their measures add to equal 180, we're going to have to get an equal sign in here. So how do we change from congruent to equals? Well, go ahead and put our equals in. What do we have to put in front of the angle symbol when we do that? We have to put that little m for measure, right? The measure of angle 1 equals the measure of angle 3. And remember, I told you, you've got to know this. Anytime we switch from congruent to equals or equal to congruent, it's called the definition of congruence. You've got to know that one. We're going to use it quite a bit. All right, let's come back up here. Ignore the bottom again. What do you know about 1 and 2? They're not vertical angles. Remember, vertical angles went across like this, or like this. What about 1 and 2? Together they form a nice straight line, right? You guys remember that? Linear pair. What did the linear pair postulate tell us? Angle 1 and angle 2 are supplementary. And I'm running out of room, so I'm going to abbreviate right there. Angle 1 and angle 2 are supplementary. Linear pair postulate. I told you we're going to use that one a lot when we started to first memorize it. This is one of those times where we use it. Okay, now, what in the world does supplementary mean? It means that the two angles do what? They add. Since I'm putting an equal sign in there, I got to go to m for measure. So measure of angle 1 plus the measure of angle 2 equals 180 degrees. Why? Well, because that's what supplementary means, right? Anytime we're talking about a meaning, we usually don't put meaning over here. We put definition of, in this case, supplementary. Definition of supplementary. Okay, it means two angles add to equal 180. Now, remember, we know that 1 and 3 are equal. So that means that instead of angle 1 right here, what can I put in its place? I can put angle 3. So the measure of angle 3 plus the measure of angle 2 equals 180 degrees. What's that called? I used to have a 1 there. I basically take it out. Okay, kind of pick angle 1 up, take it out of there, put angle 3 into its place. That's called substitution. Substitution property of equality. Okay, we have equal signs. There is no substitution property of congruence. Almost done. Well, if 2 and 3 add to equal 180, then they are what? Well, angle 3 and angle 2 are supplementary. Once again, I'm running out of room, so I abbreviated there a little bit. Why? Well, just like we did here, we went from supplementary to saying they add to equal 180 by definition of supplementary. Here we're going from add to equal 180 to supplementary. It's going to be the same reason. Remember, good definitions always work. You've heard me say this enough, now you should know it. Good definitions always work both ways. So in this direction, they went from supplementary to 180. Now they're going from 180 to supplementary. Okay, good definitions work both ways. So there we go. We just proved that the consecutive interior angles, anytime you have parallel lines, the consecutive interior angles have to be supplementary. That's what we just proved. Okay? All right, almost done. Next, I want you to look at this. What in the world's going on with this picture? I'm going to line the top line up so it's pretty much even with the top of the viewing camera or the phone or the TV or whatever you're watching this on. All right, laptop. You'll notice the bottom though is not. That means these lines are not parallel. So when you don't have parallel lines, does it look like that angle is congruent to that angle, or does this one down here look a little bit bigger? Yeah. Well, what about this obtuse angle up here and that one? Not quite the same, are they? Okay. None of these postulates and theorems work when our lines aren't parallel. We cannot say that this angle is congruent to this angle because of the corresponding angles postulate. Now, they are corresponding angles, but the corresponding angle postulate tells us they're only congruent if your lines are parallel to begin with. Since these lines are not parallel, these angles right here and right here are not going to be congruent. Same thing for alternate interior. This angle and this angle cannot be congruent because the lines are not parallel. Same thing for alternate exterior. This angle right here and this angle right here are not congruent because the lines are not parallel. consecutive interior. This angle and this angle are not supplementary because the lines are not parallel. Okay? Now, if that sounds like an inverse, it is. Okay? If the lines are parallel, then the corresponding angles are congruent. True statement. If the lines are not parallel, then the corresponding angles are not congruent. Also a true statement. Okay? Remember, inverse doesn't always mean the same thing as the original, but this is one of those times where it does. It has the same truth value or the same basic meaning as the original statement. Okay? So in this case, the inverse does mean the same thing. I want you to understand that. Okay? That's why we have to have parallel lines whenever we're using these postulates and theorems. All right, 2 quick examples that involve a little algebra instead. Okay, let's go ahead and copy this down right here. If you can't read it, it says 115 degrees up at the top. And it says 4x minus 5 down there at the bottom. And remember, we see those shaded triangles off to the side here, so that means these lines are parallel. Okay, so what do we know about those angles? Think about what term is the proper term to use. Are they corresponding? Nope. Okay, 115 is at the top right. 4x minus 5 is actually in the bottom left. Okay, are they inside? Nope. They're outside. Okay, they're outside the line, so they have to be exterior. So what do we have? We have alternate opposite sides of the transversal, alternate exterior angles. And since the lines are parallel, we know the alternate exterior angles have to be congruent, which means their measures have to be equal. So our algebra problem looks like this. 4x minus 5 has to equal 115. Well, that's pretty easy to solve. We add 5. This cancels out. 4x equals 120. We divide by 4, and we get x equals 30. Now, we don't really need a label on that, okay? It's not units, because it's not like inches or feet. It's really degrees, but you'll see we already have a degree symbol right here. So 4 times 30 is 120. 120 minus 5 is 115, and I already have my degree symbol, so 115 degrees, so that makes sense, okay? So that's one way you're going to kind of apply algebra to these. And we could do that with corresponding angles. Their measures would have to be equal, or not consecutive. Alternate interior angles. Their measures would have to be equal. Okay, let's look at this picture. Go ahead and copy it down real quick. That says 72 right there, and that says 5x plus 3. Okay, so get that copied down, then let's think about it. Are these corresponding? Nope, this is top right, this is top left. Are they alternate interior? No, that one's not interior. Are they alternate exterior? No, that one's not alternate exterior. It's not exterior at all. What about consecutive interior? Nope, that's not interior. Okay, so there's a couple ways we can do this. I'm just going to go with the vertical angle theorem. What do we know about this angle right here? Think about it. Vertical angles tells me these two angles have to be what? They have to be congruent. So that has to be 72 degrees as well. Now we're going to ignore this 72 right up here. Completely ignore it. Alright, now, got parallel lines. What do we know about these two angles? Okay, well, they're not corresponding. They're definitely not exterior, so they got to be some kind of interior. Are they alternate interior, opposite sides of the transversal? No. So they must be consecutive interior, same side of the transversal. Let's go back to our theorem. What did our theorem say? Consecutive interior angles theorem. If parallel lines, do we have parallel lines? Yes. Are cut by a transversal, then the consecutive interior angles are, there's our key word, supplementary. So these two angles have to be supplementary, right? So what does supplementary mean again? It means they add to equal 180 degrees. So we can create an algebra problem out of this. Okay, so 5x plus 3 plus 72 equals 180 degrees. Okay, let's do a little bit of like terms here. 5x plus 75 equals 180. Start canceling. Minus the 75. These cancel. 5x equals 105. Divide by 5. And we get x equals 21. Let's quick check our answer and see if it makes sense. 5 times 21 is 105. 105 plus 3 is 108. 108 plus 72 is 180. Yep, makes sense. Once again, we do not need a label on this. Okay, my label's already right here, it's degrees. And when I put the 21 in here and I do the multiplying and the adding to get 108, then the degree symbol is already on the 108. I don't need a degree symbol on the x or the 21 because then I'd have 2 degree symbols on the same angle. All right, well, there you go. That's it. So, quick review. What do you need to know? Corresponding angles postulate, better get it memorized. It's got 3 stars. Alternate interior angle theorem, 3 stars. Alternate exterior angle theorem, 3 stars. Consecutive interior angle theorem, 2 stars. This one's a little bit different because it talks about supplementary at the bottom instead of these 3, which I'll talk about congruent angles. Okay? Get those memorized, take good notes, rewatch the video, rewind it, pause it if you need to go back on a couple things and get that all written down correctly. Some of you the other day on some of your notes had things written incorrectly in your notes. And when you go to take a quiz and I let you use your notes on those short quizzes, when your notes are wrong, you're going to get problems wrong. Right? And you're going to study wrong and you're going to miss things on your regular quizzes and your tests and even into your midterm exams. So make sure you're getting your notes done correctly. All right? We'll see you guys in class, especially if you have any questions when you get there. All right?